Okay, this is my case study 7, fluorouracil and its mechanism of action. So, a brief overview, fluorouracil, or also known as 5-FU, is a pyrimidine analog that acts principally as a thymidylate synthase inhibitor. And this is a traditional anti-metabolite that works to induce cell apoptosis alongside autophagy through the activation of the p53 AMPK mTOR pathway. It is used to treat many things, such as basal cell carcinomas or cancer treatments. It works to interfere with DNA synthesis through blocking the thymidylate synthetase conversion of deoxyribonucleic acid to thymidyllic acid. By doing such, it intradermally blocks DNA synthesis. It inhibits the synthesis of pyrimidine, which ultimately affects the formation of DNA. Its structure is complex, being a heterocyclic aromatic organic compound similar to the pyrimidine molecules of DNA and RNA, and an analog of uracil with a fluorine atom at the carbon 5 position instead of a hydrogen. There is one crystal structure reported in its structure where its compound crystallizes with 4 molecules in the asymmetric unit, which leads the molecule to adopt a hydrogen bonded sheet structure. Due to such, it interferes with nucleoside metabolism and therefore can be incorporated into RNA and DNA, which leads to the cytotoxicity and eventually cell death. And above, I included the structures of fluorouracil and uracil, where you can see the difference. So, moving on to its metabolism to create a potent inhibitor. It can be metabolized by cells to create a potent inhibitor by the fluorinated pyrimidines, fluorouracil and fluoroxyuridine, being converted intracellularly into 5-fluoro-2-deoxyuridine monophosphate, which is also known as FDUMP, which is a potent antimetabolite that binds and inhibits the thymidylate synthesis. This leads to the inhibition of the formation of the thymidyllic acid, which impairs DNA synthesis. FDUTP, also known as 5-fluorodeoxyuridine triphosphate, can also be incorporated into DNA, which creates a single-stranded break in the DNA, many of those, and contributes to its cytotoxicity. Fluorouracil metabolism can also create a critical intermediate called 5-UMP, and this is essentially a phosphorylated and then incorporated into DNA to interfere with RNA's cellular functions. So, fluorouracil inhibits RNA synthesis through being phosphorylated intracellularly and then binding covalently with the thymidylate synthesis. And this leads to the inhibition of RNA synthesis. This process can occur by the 5-FU being phosphorylated into fluorouridine triphosphate, which is a fraudulent nucleotide incorporated into RNA through RNA polymerase. And this is able to inhibit RNA synthesis and therefore its function. So moving on to the mechanism of fluorouracil inhibition. This mechanism begins with the chemotherapeutic drug 5-FU, and it works to disrupt DNA synthesis through the inhibition of the enzymatic conversion of DUMP to DTMP. And this has significant effects on the RNA metabolism that contributes to the toxicity of the drug. This is able to inhibit RNA replication enzymes due to the 5-FU not having the same chemistry as uracil, yet having a similar structure. And this is also drawn out in the mechanism provided below, where it leads to the RNA damage. And here are my references. Thank you.